explain today is how a Turing machine works. I shall explain how a Turing... Hi there, my name is James Banerjee, and what I'm going to explain today is how a Turing machine works. I shall explain how a Turing machine operates by using Tim Crane's example that he provides in Chapter 3 of his book, The Mechanical... So, what is a Turing? A Turing machine is a theoretical specification of a possible machine, as described by Alan Turing. It is the idea of the smallest possible device that could perform any computation whatsoever, no matter the difficulty. The whole point to a Turing machine is that it shows the simple features of algorithms and computation. There are many kinds of Turing machines, all for different computations, but all have these same features. A tape divided into squares. A device which can read and write/overwrite symbols onto the tape. The device will have internal states, and it can move the tape left or right. What is a machine table? The machine table represents the possible operations that a particular Turing machine can perform. Crane says that the machine table is, in effect, a set of instructions in the form of, if the machine is in state X and is reading symbol Y, then perform this operation, and either change state, or remain the same. It will then move the tape to the right or left. What the Turing machine does is governed by its machine table. The following slides will explain this. Here is the machine table for the present. The input is the current symbol that the machine is reading. For this particular machine it only has two symbols, both 1 and 0. The machine states are the machine's only internal states that it can be in at a particular time. This machine only has two. So if the machine is in state A, and it reads a 1, it will change its internal state to B, write a 1 over the previous one, and then move the tape 1 squared. If it is in state A, and it reads a 0, it will remain in its current state of A, write a 0, and move the tape 1. If the machine is in state B, and it reads a 1, it will remain in state B, write a 1, and move the tape 1 square to the right. If the machine is in state B, and it reads a 0, it will change its internal state back to A, write a 1 over the 0. So let's put this machine table. The current symbol that the machine is reading is a 0. Its initial internal state is A, and the symbol is a 0. Therefore we are working from this section. The machine remains in state A, it writes a 0, as indicated by the lighter color, and then it moves the tape 1 square to the right. As you can see, we just repeat the previous process as we are still in state A, and are still reading a 0. Now we are still in state A, but we are now reading a 1. Therefore we are now operating out of this box. So it's going to change its internal state to be write a 1, and move the tape to the right. Now the machine is in its internal state of B, and its input now is a 1. It's going to remain in state B, write a 1, and then move the tape 1 square to the right. It's still in B, and its current input is now a 0. So it's in state B, and it's reading a 0. Therefore we follow the rules in this box. So it's going to change its internal state back to A, write a 1 over the 0, and then it's going to stop running. The machine has finished. Here you can see the difference between the old and the new tape. It's added 1 to the prisoner's sentence. 1 more year inside. Don't commit crime, kids. I hope this video has been helpful.